over the weekend, there was a little thing that happened on our little planet, and new discoveries, new technology, new greatness was uncovered by our NASA. And I want to spend the majority of today's episode kind of talking about this mission. But first, let's listen in to when this actually came to our humble planet.
Right now, the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here. We're about 20 seconds away. You see the team at Lockheed now, all standing ready on the edge of their seats. This team, I'll remind you, just a few hours ago, gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine. Here we go. Start your top stopwatch right now. We are 13 minutes of entry, descent, and landing. We have that expected milestone of entering into the Earth's atmosphere. We can see the team at Lockheed, and we actually have a visual now. This is from our infrared tracking camera on the WB-57, our high altitude plane, at about 47,000 feet MSL, mean sea level, getting a great view of that SRC heating up as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC is experiencing right now, as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC, a phenomenal view of that streaking SRC coming in across the sky. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah test and training range just a little bit further to the east. Entry was at. He is experiencing maximum heating, maximum deceleration. So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning, scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Once again, as I mentioned, that sample is safe and sound within that SRC, that sample return capsule, as it comes in, burning through Earth's atmosphere. You can see our high altitude plane searching for that SRC. You can see it faintly on your screen there.
Video right there of what I'll go into and explain now. But what that video was showing was this sample, which I'll get into what the sample is. Give me a little bit of time. Coming into our Earth's atmosphere, and after 9 years, we're seeing the culmination of the hundreds, if not thousands, of people's work coming together to fruition as this historic moment for our civilization is coming back to our planet and once again joins our atmosphere. And you can see how fast it was coming in based off the infrared cameras that they were using, and by doing so you were able to see the temperature and just the sheer force that was put on that particular device that it came through our atmosphere, and it got pretty hot. So let's kind of go into now and talk about what this mission was. So this is the Osiris Rex, named after a Greek god, Osiris. It was a mission to basically go to an asteroid, collect samples, come back to Earth, and then go to a different asteroid and collect more samples. Now that sounds very easy. That sounds very simple. Maybe not easy, but it sounds simple. Okay. And so far the mission has been a success. They went to this asteroid, which I'll talk about later. They collected a sample on this asteroid, That sample is now here back on Earth, being looked at by scientists from around the world, but particularly in Utah, in a particular military zone where it landed, a kind of restricted airspace for the military. And then from there on, it'll be kind of poked and prodded and looked at the contents of the samples that were collected. But this is a mission which had the goal of trying to see, one, whether or not we could perform a mission like this. This is a very complicated mission because, as we're going to talk about later, it is not easy to land on such a small object, such as an asteroid, obviously. Asteroids are not planet-sized for the most part. This was a very, compared to our world, a very small target to hit. So a amazing engineering feat, but that's not even the thing I care about. The thing I care about with this particular mission is its goal. What is the objective of the mission? The objective of this mission with the Osiris Rex was to try and find not evidence of life, which is my favorite thing, but evidence of the building blocks of what created our solar system, how we got here, how we formed, and possibly how other civilizations could form elsewhere out in the universe. And now let's watch a video of said device going and collecting a sample. And this is the first time that we have ever seen video of a probe or a craft landing on a foreign body, such as a asteroid. Obviously, we've landed on foreign bodies as planets, but as an asteroid and collecting samples and then returning those samples back to Earth, our civilization has not done this amount of stuff. We've gone to asteroids, and I believe we've returned stuff in the past, but not like this, and certainly not on video as good as this. So, captured on October 20th during the Osiris Rex mission touch and go sample collection event. This series of images show the SAMCAM's imager's field of view as the NASA spacecraft approaches and touch down on asteroid Bennu's surface over 200 million miles away from Earth. The sampling event brought the spacecraft all the way down to sample site Nightingale, touching down within 3 feet of the targeted location. The team on Earth received confirmation at 6:08 Pacific p.m. at 6:08 p.m. that a successful touchdown occurred. Preliminary data show that 1 foot wide sampling head touched Bennu's surface for approximately 6 seconds, after which the spacecraft performed a back away burn. So this is happening 200 million miles away from our humble planet when this is doing it. So first off, 200 million miles. Now imagine how far away the sun is from Earth. That's under 100 million miles. So this is on the other side of the sun when this is ultimately touching down. And now for light to get from the sun to Earth and vice versa, if we were to send let's say a radio message, send a command to a probe to say to turn right or to turn on this or to turn on that, to send signals to and from to go to the sun or something that's around the sun is about 9 minutes. Right? So there is a delay when it comes to these things. So now imagine 200 million miles. There is, I want to say, about a 20-minute delay between when you can send a signal and when you can receive a signal, just because of the sheer distance of how far away this thing is. So what they had to do in this mission was to try and get it so that they could have the probe descend and decelerate and do all of this stuff on its own. So in this video, there are no humans controlling this action. This is strictly the probe doing this on its own, and then the people finding this video, I mean, tens of minutes later, 20 minutes later or so. So that it just keep that in mind, that this is happening in real time, but in a completely different place in our solar system. Let's go right here. And we're going to get touchdown. it hits, and you can see, let's go towards the end a little bit. You see, as we're getting, let me change the playback speed to half speed. You see right here, right before, you can see the surface of this asteroid, very rocky. And now listening to kind of the people who are involved in this, they were talking about how they thought that the surface, because it is so densely packed with minerals and mostly what they believe is to be carbon, they thought that this would be a extremely tough and extremely hard surface. Unfortunately, they were mistaken. As you see this touchdown, you can see kind of just how fragile the surface of this asteroid is. So it hits, shatters that stuff everywhere, and then now you can see it kind of bouncing up and off of it, right? You're able to see that this arm, and as you can see in the little description right there, this is the touch and go sample collector. And now what this is doing is it's going into, now in here, it looks like it's dropping down and then going back up. But in reality, it was touching the ground, as it said, for 6 seconds. So it's on the ground, and what happens is, in order to get a sample of that surface, it fires gas so that the samples can be pushed into a special compartment, and then it can get its stuff up and out of there and do its collection. And so it is actually called the touch and go sample acquisition mechanism, is this actual little arm that you can kind of see right here that extends into the surface right here. So this little white section on the underside of it, there is a little basin that they use to collect the surface sample right here. So as it touches down, I'll try and get right on it when it makes contact. So this is pretty much contact right here. Then it shoots out gas to try and get some of that material on the inside. And then it fires its boosters and it kind of gets up a little bit. They were not expecting it to be as soft in its surface as this, because I mean, if you look at this right here, it appears like it's a solid rock surface, but that is not the case. And right here you can see this is a series of 2 images which shows the moment before and after the spacecraft touched down on Bennu's surface. And then it talks about the sampling. Here's another video of it as well. You can kind of see right there, just this stuff kind of going everywhere, rocks flying all over the place. Now, I don't think that this event really caused any real damage to this asteroid Bennu. However, it certainly was not what scientists were expecting. They were expecting a much harder surface. Now, let's kind of get into, what is this mission? What the hell is this, and why do I care? All right, we have some frequently asked questions. What is Osiris Rex? On September 24th, 2023, NASA Osiris Rex became the first U.S. mission to deliver a sample of an asteroid to Earth. The spacecraft, which launched September 8th, 2016, collected rocks and dust, an estimated 8.8 ounces or 250 grams from the surface of asteroid Bennu on October 20th, 2020. After further study of the asteroid, the spacecraft began its cruise back to Earth with the sample on May 10th, 2021. The material gathered from Bennu acts as a time capsule from the earliest days of our solar system and will help us answer big questions about the origins of life and the natures of asteroids. So the main goal of the mission and why they particularly chose this particular asteroid is because of one of the contents of the asteroid, which we'll get into later, to see what exactly the earlier universe looked like, because this asteroid is many believe to be older than our entire solar system. So this thing has been here for a very long time, and the contents that make it up potentially have broken off and gone into Earth and helped to spark the creation of life on our planet as we know it. And I wanted to show this video of the NASA team. This is NASA's chief science director, I believe, is her title. And let's hear what she has to say about the mission.
Earth science, an expert on how our planet works and climate. Can you tell us how this asteroid mission and the samples we return might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid Bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
Okay. Kind of get an idea of from the actual scientists as to the goals of this mission. For me, finding life elsewhere in the universe is fascinating for me, but also finding reasons for life on our own planet is probably equally as fascinating, because there are a multitude of steps and a multitude of events that have happened in our past that has led to life here on Earth. So let's mission broke so many records because it went to this particular asteroid, collected these samples, then came back to Earth. The mission is still not over. They're still sending that probe to another asteroid, which is something that we will cover probably in 2029. But getting back to this, so gets the sample and is coming back to Earth. I mean, just the sheer amount of people that it took to be involved in this thing to put it together. Bravos to the team. I do suggest that you go watch that full stream from NASA's website. It's actually just this video right here. This is the entire stream. I mean, if you want to, we can kind of go
That crosshair
forward right here. This is
colored parachute.
yeah, so this is kind of right here. And you can see it like that's landed on the ground. I mean, I don't think in real time I'll be able to get the actual. I don't think I'll be able to find it actually landing, but yeah, so you can kind of see, I don't want to get too caught down in the weeds or anything right here, but it goes on, and you can even see in the before stream, but they did a great job. These groupings of people. She was on site on the actual retrieval location, so she talked about the exact kind of operations that it took, that once it gets on ground, how do they get it to a facility so that they can analyze the data on it? And then they have these studio hosts to kind of talk about the mission itself, to talk about the importance of this mission. You can see this little graphic right here of the probe being sent to our planet. But I really do encourage you to watch the entire thing. They even have, I mean, if you know who this guy is, you know some good music. But he talks about he talks about the mission a little bit himself, a famous rock star talking about a famous rock. I mean, very cool right here. They have different things. So just I encourage you to go watch that. And they also go through the entire sequence of actually getting this into the research facility. This is a live stream of the whole process of getting it there, and you can kind of see Boom. Right there. We'll get to the final seconds right here. Very, very cool. So yeah, make sure you do go watch that. But kind of getting back to my main point, hopefully with this mission, there are a couple of things that obviously I would think that are extremely important. One is finding out the contents of the samples collected, particularly, is there water there? Is there carbon there? Is there certain elements that would have been present, not currently on Earth, but currently, if we're talking in terms of the creation, we're talking 2 to 4 billion years ago when the Earth was still being formed, which they believe is the makeup of this particular asteroid. What is the actual scientific importance of these samples collected and whether or not there are these things that scientists are looking for? Now, we are fairly certain that there is carbon in this, but they're going to see if there's certain carbon types, like certain things called isotopes, which I'm no chemistry major, but before I speak further, let me search up isotopes before I start talking out of my ass. Isotopes meaning, and then isotope. Noun. All right. Each of 2 or more forms of the same element that contain equal numbers of protons but different numbers of neutron in their nuclei, and hence differ in relative atomic mass but not in chemical properties, in particular a radioactive form of an element. All right, people. All right. Yeah. Isotopes of carbon. All right, so there's carbon 12, carbon 14, 13, 11, 20, all these things. Very cool. Differences. All right, now we're getting into too far into the weeds. All right, very cool. But now let's talk about Bennu. What is this place? What is this thing? Discovered in 1999, it is a small near-Earth asteroid that passes close to Earth about every 6 years. And that's an image thanks to this recent mission right here. Kind of see an overview right here, some images. Here it is. This is a live, not exactly a live view, but this is where it is currently located right now. So you can see that's Bennu right there, and I'm gonna kind of back out right here. Boom. So with Earth currently right there up at the top of your screen, it is basically right next to Venus, separated obviously by a couple million miles. But yeah, there it is. It's still orbiting right now. This is a live look at Bennu. Very cool. All right, 10 things to know about Bennu. Found in 1999, discovered by the Lincoln Near-Earth Asteroid Research Survey on September 11th, 1999. Named by a 9-year-old. Very interesting. Original designation was 1999 RQ36. In 2013, a 3rd grade student named Michael Buzio won a contest to name the asteroid. I mean, that's what you come up with? Bennu? All right, Michael. Let's get it together. Bennu has drifted into near-Earth space because of its gravitational interactions with giant planets and the general push of heating from the sun. You can kind of see this image right here. It is kind of easier to, when it's put up next to these images, to kind of see the size of this thing, which I think is cool in more ways than one. All right, so number 4, low density. Bennu's density is only about 30% more than water. This suggests the asteroid is probably a loose collection of rocks, like a pile of rubble. And as you could see in that landing, they were not expecting it to be as loosely packed as it was, which is very interesting to think about. Coming up next, it has a close approach to Earth every 6 years. Scientists estimate Bennu has a 1 in 2,700 chance of impacting the Earth during one of its close approaches to the Earth in the late 22nd century. So both you and I will most likely be gone by that point. Burn up or bolt. Bennu may burn up in the sun. Over millions of years, all of the planet's Bennu is most likely to hit Venus. Very interesting. And as you saw in that live locator earlier, it's right in line with Venus currently. Number 8, big boulder. The boulder that jets from Bennu's south pole is about 164 feet high and 180 meters wide. And I wish they would show that. I mean, I don't know if I'll be able to find that, but in the NASA broadcast, one of the things that they talked about was as they were orbiting the asteroid, they didn't run into this boulder, but they came in contact with it and they didn't realize just how big this was. And so they almost ran into it as they were orbiting around because they got extremely close to the asteroid before they actually landed. And they almost ran into this thing just because they couldn't see it. And you're dealing with a probe that you're not getting instant feedback. The signals that you're sending take a long time to actually get there. All right, number 9, moonless. Although some asteroids have moon, Bennu does not. All right, NASA's Osiris Rex mission studied Bennu in unprecedented detail. It collected a sample in 2020 and delivered it to Earth 2023. So why Bennu? Bennu is relatively close to Earth. It's really old and well preserved. It might even help us in our search for clues to the origins of life and learn how to preserve life by keeping near Earth asteroids at bay. All right. Overview. Okay, discovered mean orbit velocity. Is there something that I'm trying to find? Look at that. There's a different. Wow. All right, not what I was looking for. Maybe in depth. All right, an ancient relic of our solar system's early days. Bennu has seen more than 4.5 billion years of history. The best evidence suggests that within 10 million years of our solar system formation, Bennu present-day chemistry and mineralogy was already established. Because its materials are so old, Bennu represents a type of building block of our solar system's rocky planets. It may even contain organic molecules similar to those that could have played a role in the start of life on Earth. Then going further to talk about the size, as we know, it is very small, and it kind of gets into here what on that previous slide we saw with the kind of side by side to the Empire State Building. So it's about 1/3 of a mile wide at its equator, and it's not a perfect sphere either. Bennu is minuscule compared to the planets. In fact, it is only slightly wider than the height of the Empire State Building. By comparison, the smallest planet, Mercury, is more than 3,000 miles across. So this is why it's called an asteroid, not a planet, and why one of the reasons why, and I'll talk about this more in detail, why it is just insane to think that we are able to land a small little craft. Yes, it's about the size of a school bus, but still a small craft from our planet onto something that's about the size of, or about the width of the Empire State Building. I mean, an insane accomplishment for our civilization. Right, and then orbit and formation. And now let's get into the formation. Now this is all likely. Bennu was likely broken off from a much larger carbon-rich asteroid about 700 million to 2 billion years ago, which is relatively recent in geological time. It is likely formed in the main asteroid belt between Mars and Jupiter and has drifted much closer to Earth since then. Scientists think that a cataclysmic collision caused a carbon-rich asteroid 60 to 130 miles in diameter, roughly the size of Connecticut, shout out, to break apart, scattering pieces, including Bennu. The asteroid has wandered into near-Earth space because of gravitational interactions with giant planets and because of the long-term Yarkovsky effect, the small force on a spinning body due to its absorbing sunlight and re-emitting the heat as infrared radiation. And there you can see the shape of this thing right here. Very cool. All right. Structure. All right. Yeah, they don't know exactly so far what it's made of. They're still trying to see. And then the final thing right here, potential for life. Unfortunately, I don't think we're going to be able to find any life forms here, but Bennu does not appear to have the condition necessary for life as we know it. Temperatures range from a toasty 240 degrees Fahrenheit to a frigid negative 100 degrees Fahrenheit. Because there is no atmospheric pressure, the liquid water cannot exist on or under its surface, which stinks. Yeah, significant events, all this stuff. Now let's go into galleries. Now, last time when I was doing prep, okay, some of these didn't actually load. So yeah, you can kind of see. Here's an artist concept list. Okay. So can I zoom in? Command plus. Okay, that's not gonna work. Good Lord. Maybe that. All right, that's the best that I can do. But you can see right here, this is the descent into that object which we saw basically right here. So this is what it would have looked like if you were an observer on the surface. So this huge long arm, and right at the end of it, I know I can't go zoom in onto it, but that little end piece right there, that's this thing. This little collector right here that ultimately got the samples from Bennu. Very, very cool. Now, let's go a little bit more right here. You can see the difference in size between this, the Empire State Building. So this is 510 meters compared to 443 meters for the Empire State Building height, and the Eiffel Tower 324 meters of height. So, and in comparison to buildings, it's big, but in comparison to other even asteroids, it's not something that's completely out of the ordinary. It's not super big. It's not crazily out of the ordinary. It's just able to have us land on it. So very, very cool stuff there. All right. Now let's go big picture. Big picture. Last week, I told a story about, or there was a story about approximately 1 million years ago, there was evidence of human life on this planet where there was a massive extinction event that almost wiped us out. And I think last week, if I remember correctly, oh no, not last week. This was two episodes ago. Sorry. But talked about just how fragile life is on our planet. And life is fragile on this planet. Imagine if Bennu collided into our Earth now in 2023. That would be the end for a lot of folks. Now, fortunately for us, it's probably not going to do that, but it still potentially would end most civilization if it collided with our planet. So that is something to keep in mind. But I do want to kind of talk about, and not trying to bring faith or religion into this, but what were the steps throughout the entirety of our solar system, throughout the entirety of our galaxy, throughout the entirety of our universe, which led us to this point? And there are billions and trillions of things that had to happen in order for me to be sitting here speaking to you about this. And I want to stress the importance of appreciating the fact that we're here. And hopefully with stories like this, with doing analysis on the particular objects that are collected as samples, or even the study of Bennu as an asteroid in and of itself. I hope that we can find evidence that life here on Earth was mostly due in part to asteroids. I hope we can finally get an answer onto how life got here on Earth, because if you've listened to people such as Joe Rogan, they've theorized, and I don't think he's super serious about this, but he has proposed that maybe much more intelligent alien civilizations came down here to Earth to seed the planet, to bring life here onto our planet. Now, I'm not certain that that's what happened. I obviously do not know if that's what happened. If we were just chimps and just whatever life forms we currently were, and then from the heavens, another civilization much far more superior than us in terms of technology and intelligence came and dropped off some things to speed up our development and to create us in what we are today. I'm not saying that that didn't happen. I'm not saying that I don't want that to happen. I mean, if we get an answer on how we were able to get here, a definitive answer, I'm all for it. But with this particular mission, I feel as though there will be some secrets that are unlocked. However, how you react to the information that comes out, whether they say there is liquid water on here, there is carbon on here, and what this means is that we are very confident in saying that life here on Earth was actually jump-started by asteroids such as this one. And I think that ultimately that will be the case. However, our species as a whole has gone from on all sides across the world. There have been civilizations which have prioritized science, math, exploration. And then there have been other societies which have done that, but they've also been interested in war and conquering different places, and even not so negative things such as trying to invest in the arts and in culture and in philosophy. These different things that our society and our civilization as a whole has talked about and theorized and come up and put together these different ideas of what makes a good civilization. And over the course of millions of years of evolution and certain events that have brought us here, we are here in 2023 with so many things in our world awry, so many things not going to plan. I mean, there are more examples than I could think of right now, but I've talked about many of them, especially the big one right now is the Ukraine war. Our society at this point has come so far, and we're not a perfect civilization. We're not a perfect planet, but there should be some hope in people's minds that we have the ability to take a large group of people, put together a mission, go out to 200 million miles away to land on a small rock that is just about as wide as the Empire State Building. And it's hard to hit a target like that when you're 200 million miles away. And it's hard to hit that target when there's a delay of tens of minutes, maybe 20 minutes of delay from when you send a signal to when it receives it and is able to do anything about that. There are so many instances of where this could have gone wrong, where the mission could have been over, but thanks to the experts who put together this mission, they were able to do so. And I hope that this is one of many examples of people, regardless of whether they're Trump supporters, Biden supporters, neither supporters, whatever, people who have these differences come together to find answers of to what exactly are we? Are we unique? What exactly were the processes that it took to get life on this planet? And for me, is this something that we could do elsewhere in the universe? Now, I don't think that this is something that they're thinking about. Well, one thing I would think about is, could we do something like this to a different civilization, to a different planet? Could we potentially send these building blocks in a form of a care package to a different planet? Is there a possibility that we find an exoplanet that might be 5, 6, 7, 10, 20 light years away, so very far away, but we know because of this mission that these certain carbons and certain water molecules and certain whatever is very important to the jump start of creating life. And now, one Bennu asteroid doesn't mean that all life on Earth was created by it. There's many of these. However, if we can potentially send a care package of these molecules, of things which we discover through the study of this, find that to help jumpstart the creation of life, you need these certain things. Could we potentially send a little gift to a far distant planet to help get life started there? I'm not sure. I hope that we are able to do something like that, because I think ultimately the creation of life is one of the most, if not the most important thing literally in the universe. Now with creation of life, there is a lot of responsibilities. You can ask any parent. Yes, step one is to create life, but then the next 10 million steps are creating a good human. And I hope with missions like this, we find some answers about our creation, about our evolution into what we now are today. And I hope that it is a message to many of the people in NASA and hopefully in our government and across the world that we are quite possibly extremely lucky, and quite possibly this is the only planet that this many things has happened to. I mean, we might be alone. And if we are, what is our responsibility? Is our responsibility to try and expand from this planet to go to Mars, and then maybe to Mars to another planet, maybe potentially a moon of Jupiter, whatever it may be, to try and populate our own solar system? Is that the plan? Or is this something where we send out a care package like I proposed earlier to a faraway land that when it gets there, it's able to release these molecules and compounds that could jumpstart life and begin life in a completely different place of our galaxy? I do hope that we are under no obligation to believe that this is it, that this is just where life ends. I hope that we can think of thousands and thousands of years in the future and think about future civilizations which could be helped by our civilization, by us sending out probes that could deliver life to elsewhere. And maybe by doing so, we can instill some of the best aspects of our culture into there, of love and appreciation of the arts, movies, comedy, whatever it may be, video games, whatever it may be that you think is the best of our society, that we could transport those ideas and those ideologies to different places in our universe. I hope with this mission that we are able to discover, one, how lucky we are, and whether or not this is duplicatable. I hope that we're able to find this out, and I hope that our civilization will be able to hopefully come together in some form of agreement about the importance of this mission, and with the continuation of the mission to that other asteroid, to hopefully in the future find some defense mechanisms against asteroids that may come in contact with Earth in the future, and how we could get rid of those. Because now that we're able to land on these things, why not, if you have one that's going to come in contact with us in 20 years, why not send a rocket up to it, land on it, and explode? Try and divert its path so that it doesn't hit Earth. I mean, that would be an incredible thing for our civilization, because obviously we don't want to get hit by one of these things. In the past, it was very important for these to come, because if they contain water or they contain certain elements like hydrogen or oxygen or these different things that could help jumpstart and create life on a planet, that was very good to have in the past. But at this point, we don't really need that much more oxygen. We don't need that much more water. We kind of got things settled right here, right now. But what we do need is a defense against these things. Because if in the future something the size of Bennu tries to collide with our planet, now we have a little bit more expertise of landing on these things and potentially diverting their path. So, very excited for this mission. We're going to continue to keep my eyes on this mission, but let's just wait and see, folks. Let's just wait and see.